Okay, welcome everyone to today's CSIA webinar, Path to a Secure and Robust Industrial Control Network. My name is Colin Hammond and I will be your host today. For those of you who are unfamiliar with CSIA, we are a global nonprofit professional association with over 500 member companies in 40 countries. Our mission is to advance the practice of control system integration to benefit our members and their clients. Our vision is to ensure that manufacturing and process industries everywhere have access to low-risk, safe, and successful application of automation technology. CSA membership offers members access to resources needed to attain and exceed business goals. To highlight just a few of our many member benefits, the CSIA Best Practice Manual guides control system integration companies in the setup and running of a solid company. CSIA's Business Insurance Program offers members an excellent insurance program for business owners, subcontractors, and more. The program includes members from all over the world enjoying the peace of mind that comes with CSIA insurance. Clients in all industries are now seeking integrators with the CSIA certification alongside ISO. They recognize CSIA certified integrators' commitment to industry standards and business acumen. As a result, being certified can shorten the sales cycle. CSIA Industrial Automation Exchange is the premier automation guide featuring system integrators and suppliers who provide industrial, manufacturing, and process automation solutions. For integrators and suppliers, it's a place to market their expertise. Clients will find white papers, case studies, capabilities, contact information, and engage in conversation directly with CSIA members. Please follow CSIA's online events calendars for all upcoming webinars, including both partner webinars and business webinars. CSIA's business webinars feature topics handpicked by CSIA leadership to help you run your business. CSIA's partner webinars are opportunities given to CSIA's industry partners to address hot topics and demonstrate their expertise. You won't want to miss these opportunities to learn from the comfort of your own office or home. For more information about CSIA, please visit our website or contact us at info@staff.controlsys.org or 847-686-2245. At this time, I would like to introduce our presenter. Larry Great has been working in the industrial automation industry for over 30 years, delivering solutions in a variety of industries using DCS platforms, PLCs, and various SCADA systems. For the last 5+ years, he has been working in OT network convergence, leveraging ICS data to improve operational efficiency for our customer base. Over the last 3 years, this has included architecting solutions to secure OT ICS networks to IEC 62443 and related cybersecurity standards from identified threats. Larry is a professional engineer registered in the state of Georgia and holds several Cisco certifications as well as a GICSP. Additionally, Larry is the president of the Tennessee CS2AI chapter, and I'll now turn it over to our distinguished presenter. Hey, welcome, Larry.
Thanks, Colin. I appreciate it.
Thanks.
So, looking forward to sharing with the group as a whole just a number of steps that we've worked with our customers essentially to deploy over the last several years. So I've got a number of things to talk about. This was the abstract that we put together for this, and there's one thing I want to kind of point out in here because I have a coworker not a coworker, I have a friend in the industry, I guess, that doesn't like the word converged, and his motivation for not liking the word converged in terms of OT and IT networks is mainly because oftentimes it's not well defined. And so for the context of this presentation, I want to point out that we're talking about the whole of this as being necessary for convergence. And the biggest reason for that is that most manufacturing networks today still operate entirely unencrypted and authenticated. And so if somebody gains access to them, they can very quickly own the customer or end user that they've gained access to. And that's my colleague's concern, I guess, with the word converged. So for an agenda today, we're going to kind of walk through creating goals for why you're trying to merge these two networks, what it takes to assess your current state, how to take the goals that you put together and the current state and think through what that means and what the impact is. Take that information, use it to design an architecture, develop an implementation plan, and then at the end make sure that you've got a mechanism in place to not only test but monitor what you've installed so that your customers or end users have an opportunity to understand the condition of their network. So, what's necessary for creating goals? A couple of things I want to point out early is, be realistic about where you are and the skill sets that you've got. Oftentimes, especially people in the manufacturing space, want to own their network, there's a lot of friction typically between an OT or controls engineer and your IT department. We've really got to get over that. We can't do this without each other. We need both sides of the party to come to the table and have a conversation. And the other comment I'll make related to that is oftentimes those conversations, we don't realize it, but we're using the same words with different meanings. And so we need to make sure that we're actually communicating to either the security or the IT professionals that are in the room to make sure that we understand each other. A couple other thoughts. Make sure you understand where the senior management of your company is, or your customer's company is before they start heading down this road. Understand what their goals are, what they're trying to accomplish, and make sure that that's clear and concise as you go through the process itself. Already kind of mentioned identifying stakeholders early. Make sure that you've got an IT representation, a manufacturing representation, and somebody out of the security group, if that exists at the company that you're working with or as an end user, in order to make sure that what you're architecting and what you're putting together is concise and consistent.
Hey, Larry.
Consider. Yeah.
I'm sorry. I'm just going to jump in real quick. We got a few questions. It sounds like they can't hear you that well.
Okay.
Is there a way to maybe get that?
Yep. Let me turn off the Bluetooth and see if it works better. Straight into my phone. Is that better?
That's a lot better.
All right. My apologies.
Okay. Thank you.
Okay. Yep. So as you're talking about creating goals, a couple other things. Keep in mind what security tools you might deploy later. So as you're developing goals for the network design, make sure to consider things that you may eventually want to do, like an intrusion detection solution, how you might deploy SIEM aggregators for looking at syslog traffic across the entire network, and what you intend to do from a network monitoring perspective. We actually were working with a large food and beverage customer, and it was kind of an interesting process. Early on, we were basically doing an initial assessment that we'll talk about in a little bit. And when we got done, there were a number of things that the security group intended to do eventually that really weren't part of the original picture. And by including those things, we were able to re-architect the solution to meet that customer's needs long term. Okay, with that said, what are the real reasons that you're probably converging? Likely didn't have those in mind. Likely your customer or an end user was headed down the road of saying, okay, I'm looking to do OEE. I really want to get some key process indicators put together and get some visibility to that so that I can get workforce buy-in. Maybe looking to implement some model-based control or some machine learning solutions to predict maintenance. Maybe looking to provide remote assistance or AR-type solutions. Actually, it may be counterintuitive, but they may be looking to converge for cyber risk reduction. They've got this system out there they've got no visibility to, and they want to understand what's going on it. And in order to do that, the tools that they intend to leverage are actually sitting on the IT side of the house. And so how do we integrate those in a secure manner? They may have IoT solutions for doing predictive maintenance types of things they're looking to do.
And they may be looking to do obsolescence risk management, right? So if I've got a network that was poorly architected, it's not terribly robust, maybe it's creating me some downtime, and I'm looking to see what I can do to actually improve that overall design and architecture. The reason for considering all these things is to consider what throughput you need in the different areas of your network in order to meet the requirements. So if I'm doing KPIs, if I'm doing OE, if I'm doing remote assistance, I need to make sure that my network has the capacity to be able to handle the additional traffic that it's going to carry as a result of these new features and functions that it was not doing previously. Oftentimes we've designed manufacturing networks using unmanaged switches, low-speed connections, things of that nature, and we really have to evaluate from a bigger picture where we're at. And so the last item on the list is anything else that might impact network bandwidth, right? So anything else that I might do as a result of making this change that would impact how much information I can move in and out of that. We were working with a large glass manufacturer as an example, and they had a number of things they wanted to do from an analytics perspective that was going to require getting a substantial amount of data out fairly low in their network. And we actually created separate VLANs and paths essentially for that network traffic in order to prevent it from being an impact on their human-machine interface performance. So next thing, once I've decided what it is I'm trying to accomplish, is to determine where I'm really at. A couple of things I want to point out here. If you're an end user trying to do this and you don't have the internal expertise to really understand what you're doing, reach out to your control system integrator partners and or IT house to get some help with that. One thing I do want to point out if you go the IT route is that most traditional IT vendors don't understand the manufacturing environment. There are a lot of differences in the manufacturing network architectures and designs that are not typically things that they think about. And so make sure that if you go down that route that you keep somebody from a control perspective involved that understands manufacturing networks to be able to help them avoid the blind spots. Depending on the state of your current network, you may or may not need to do a detailed architecture drawing, so why wouldn't I want that? Well, if I know that my architecture is not something that I'm going to carry forward, I'm essentially going to do a rip and replace, I probably don't care a lot about what the current architecture is. I'm really just trying to get at the information that's moving around inside that architecture to understand what the baseline traffic rates are so that as I design the new system to replace that, I take into account the current traffic plus the additional traffic that I know I want to pick up as I went through my goal creation. Make sure and collect information on port utilization, specifically where things start to converge, so where I've got multiple switches starting to come together. Make sure those northbound ports, you understand the traffic rates through those ports. And the last point I'll point out is if you're using automated tools in doing this, be careful. Oftentimes, manufacturing networks are very sensitive to latency and jitter depending on what you're doing, especially if you've got motion out there. And there are also known vulnerabilities, unfortunately, with a lot of OT devices. And so something as simple as what an IT person would consider to be a benign Nmap scan would actually mean sudden death for a lot of OT devices. And so understanding that is key. The other thing I'll point out is oftentimes manufacturing networks were deployed without using managed switches. Can't tell you the number of devices, even in our history, that we've deployed basically early on, where down at the low level 1 of a Purdue model, for example, there's a number of switches out there that are unmanaged. Those automated tools don't give you a lot of good, useful information in that situation, right? So is there value in assuming the risk associated with running those tools? If you've got managed switches out there and you've got SNMP configured appropriately, then you can get a lot of good, rich information out of that system. Consider the impact of your goals. So now you have an idea of where you're at. You have an idea where you want to go. Start to overlay those two and consider basically where the choke points in your network design are. Questions to ask yourself, and we've already kind of mentioned, where you've got transition points in the network, is there sufficient bandwidth to handle that? Am I deploying a redundant topology? And if so, am I using an appropriate redundant topology for the type of network system that I'm deploying? Oftentimes we don't really think through what we're doing from a redundancy perspective. We may apply a ring topology, for example, in a place where that really isn't appropriate because of the number of devices that are going to be in the ring or the fact that it's not resilient for multiple failures. So redundant star topologies are things that you can use in place of that. Understanding where those are appropriate to apply and how to do that can be very important. And the last thing I'll point out is, do I understand how the varying hardware vendors in my network are going to interact with each other? And I'm really not talking about endpoints here like, Rockwell versus Siemens versus Schneider. I'm talking about the manufacturers of the switches themselves. So if I've got an existing network that's got 4 or 5 different manufacturers out there, I've got some Hirschmann and some Cisco and some Stratix and a number of others, do I understand how those are all configured to make sure that I'm not going to deploy something that's going to interact in a way that I don't intend for it to? Consider, as you're doing this, not only your IoT, but also your IT initiatives. We've already talked about security and kind of understanding where that's going to go. So the next step is really designing your architecture. So what's important in doing that? A couple of key things. Make sure you engage your OEM. If you're a Rockwell user, a Siemens user, Schneider user, understand what they recommend from a best practice perspective in terms of architecting a network. Make sure as a part of that if they have a validated design, for example, if you're Rockwell, well, they and Cisco spent a lot of time together creating what's known as the CPWE standard. That's actually a Cisco validated design. So if you adhere to that standard, you're essentially guaranteed to get the performance that's a part of that architecture. It's already been tested, it's already been run through and looked at different failure scenarios, and they've got different prescriptions for how to do redundancy and so on and so forth. And so it's key to understand what that vendor is really providing and how you would go about deploying that. Obviously, you want to document your configuration, and as a minimum, that should include these things. Understanding spanning tree root bridge, right? So spanning tree is a network topology that was basically built. A lot of people think of it as being something to prevent loops. In reality, it was created to provide for redundancy. As a result of providing for redundancy, it provides the ability to prevent loops. Unfortunately, there's a number of different variants out there, and so depending on what switches you're using and what they default to and whether or not you intentionally configured that, you can actually have interactions with spanning tree that cause network instability and problems. There's a number of vendors, for example, that out of the box, if you don't make configurations that are sitting side by side on a network, i.e. say Intron and Cisco or something of that nature, they actually don't play well together. In fact, even Cisco and Stratix, unfortunately, despite the fact that they're built on the same iOS, out of the box have a different version of spanning tree, and you need to be intentional about how you configure those. Understanding who's going to become the IGMP querier on a network. A lot of manufacturing networks today no longer use multicast traffic, but if you've got legacy hardware out there that's still doing that, that querier functionality becomes key to the performance of the network. And so knowing where that's going to sit and designing it to be there is very important. Understanding how you're going to do routing. A lot of times we've architected very large flat OT networks. We really need to get away from that, both from a security and a network architecture and performance perspective. We don't want routing to be part of how the basic process runs. So we don't want I/O, for example, to be routed to a PLC processor. But we probably do want PLC processors routed to each other and or HMI systems potentially routed down to those PLCs. So where am I going to do that at? Obviously, that becomes key to the process. How do I make that redundant? Those kinds of things need to be a part of what you consider in your architecture. How you're going to implement virtual LANs. This is great for segmentation, great for security, great for improving performance, but you need to think up front, how am I going to do that? How am I going to architect that? And then how am I going to apply IP address schemes within those VLAN designations? Finally, a lot of times this gets overlooked, quality of service policies. Depending on what you're doing with your network, if I'm doing motion, if I'm doing safety, if I'm doing things of that nature, those are definitely things that use quality of service as a part of the network packet. If the switch doesn't interpret that correctly and view, for example, a time update message or a motion message is more important than something else on the network, you can end up with very poor network performance from a manufacturing perspective. So another thing on designing your architecture, I think I skipped a slide here, my apologies. Let's go back one. Make sure that you are intentional about how you go about deploying the basic media that your network is going to reside on. So how am I going to architect using copper and fiber? Make sure that you adhere to TIA standards as you do that. One thing that's we've seen a lot of people get in trouble with is they'll go deploy a DLR network or something like that in a Rockwell environment, and they don't actually test all the different links. And unfortunately, DLR doesn't do a great job of telling you when you've got media problems. And so you really want to test every cable before you put it in service and know that it's good. And I'm not just talking about a continuity check. I'm talking about a full sweep TIA check to say, does this meet gigabit network standards? Same things for fiber. Make sure that you're testing the loss on your fiber media to understand the state of all the different fibers, both the ones that you plan to put in service and any redundant fibers that you're installing essentially for future and or as a backup in the event that you had a failure of some kind. Generally speaking, recommend using fiber for trunk connections and redundancy conversion speed. One thing a lot of people don't realize is if I'm doing a redundant ring or things of that nature, fiber converges much faster than copper does. Unfortunately, it's not about what somebody could do, it's about adhering to the IEEE standards. And so because of the way IEEE standards are written, the switch has to wait much longer to determine that a copper connection is down than it does that a fiber connection is down. Obviously, using 600-volt Cat6 shielded cable where it's appropriate if you're installing Ethernet cable in an ECCs, things of that nature. Keep in mind that your manufacturing environment is not your typical IT clean room. And so there's a lot of good information out there around what's known as MICE, or mechanical ingress, chemical, and electromagnetic interference. There are industrial devices that are rated essentially as each one of those letters, so MICE has a rating from 1 to 3. 1 is the lowest, 3 would be the highest, so an MICE of 1111 would be a typical IT switch, whereas an MICE rating of 3333 would be something hardened and designed to put into an industrial environment. Consider, the standards that are out there from an equipment supplier perspective. If you're going to have somebody come install this network for you, you can look for things like, is that vendor Panduit 1 certified? One of the nice things for those that are is that provides you, if you use all Panduit equipment, there's obviously a cost associated with that, the reality that Panduit offers a 25-year warranty on that installation. So there's some nice things about that. If you and then you're adhering to best practices, right? They're going to do the testing to TIA standards. They're going to provide you all that information. They're also going to come back if you don't generally have appropriate use of patch panels and things of that nature. They're going to make recommendations basically on where you should be doing that differently potentially to be sure that you've got something that can be maintained long term and that's sustainable. So we can't ignore the word secure as a part of this. So really at this point, and I realize a lot of you may or may not, or end users may or may not be at a point yet where they're ready to do a detailed cyber risk assessment, understand that. But you can do a high-level risk assessment. If you've never seen the CSET tool, that's a great tool available for Department of Homeland Security. It's downloadable for free. Basically lets you pick a standard like NIST SP800 and say, okay, I'm going to put together a list of questions just to run somebody through to think about how they're architecting and what they're doing from all the different security controls perspective. So that's a great way to get started. Of course, there's great standards out there like IEC 62443, which is the old ISA S99 standard. That's very helpful as well. Some things to consider, and some of these aren't necessarily directly network related, but as you're doing all this, it kind of helps you to think through, again, how am I using this network? What else might be on that network? How are you going to handle vulnerability or patch management? How are you going to handle server infrastructure hardening, which is basically the process of turning services off that you don't need, configuring servers so that they don't accept just any message that comes in, but look for authentication where I can do those types of things. How do you handle legacy hardware? Do I need to do whitelisting, things of that nature? Should I do things from a network segmentation and firewall deployment perspective to allow me to protect my critical assets? If I have a safety instrumented system or something of that nature, I want that probably to have additional security controls in place over maybe just a standard PLC that's doing basic control for my machine. If you're not familiar with it, the concept of an IDMZ or an industrial DMZ. Oftentimes IT folks deploy those essentially between an enterprise network and the internet. IDMZ is meant to sit between the manufacturing network and the enterprise network and provide that place where I can do secure protocol translation and things of that nature. And so becomes critical for providing secure patch management. Maybe that's the place I put my patch server, the place I put jump servers, things of that nature. Think through where are my most valued assets? Where are the things that I am most concerned about, and how do I defend those areas? How are you going to manage remote access? So what is the mechanism that I'm going to allow somebody through an IDMZ to get to an endpoint and be able to provide remote assistance. Again, those protocols are unauthenticated, unencrypted, so you probably need that engineering station to be something that exists on the manufacturing side of the network, and what you're really using that IDMZ for is a mechanism to allow an RDP protocol or something of that nature to that engineering station, rather than allowing somebody to go directly online with a PLC from outside the company. That assessment should result in some appropriate security controls based on where you're at. Oftentimes that's going to be very minimal in the beginning, and as people start to deploy things and think through what they're doing, they get an opportunity to go a little bit deeper and think through what they want to do. But if you've designed that network for the types of things that you want to do eventually, then you don't have to go back and readdress an architecture that may not be sufficient to handle what you want to do from a security perspective. So next thing, I've got all this together. I've thought through my security. I've thought through my architecture. I know what my available bandwidth needs to be. I need to put together an implementation plan. So I need to think through how would I go about doing this. Obviously, I can't take the entire site down probably to go install this network. So do I put it in parallel with what's there and then move assets slowly over time? Do I have scheduled outages, maybe an annual turnaround or something of that nature that I can take advantage of and move chunks of equipment? And then as you're doing that, think through, okay, maybe I'm going to readdress everything as a part of all this. How am I going to allow the old IP addressing scheme to communicate with the new IP addressing scheme as I go through that process of migration over time? And having thought through that up front helps you rather than getting to the 11th hour in an outage and realizing that you've got a problem. It may require additional personnel to support new systems. The reality is that what you're putting in may not be something you already have staff on hand to handle, and so you may have to hire additional people to help provide the support necessary and things of that nature. And there are vendors and other people that provide that on a contract basis. You just kind of figure out how you want to go about solving that problem and make sure that you've thought through that and have some understanding of how you want to do that. Of course, from there, you're going to put together appropriate capital projects and then go through and execute your plan. I'll mention one thing, I guess, related to a food and beverage project that we got involved with as well, and it was kind of an interesting process. We got down to the end of it, and the final number was something that the manufacturing department just couldn't swallow. Oftentimes you look at the cost of managed switches, things of that nature, and people with a controls engineering background are used to paying $300-400 for a switch, and so all of a sudden paying $1,500 for a managed switch becomes, why would I do that? And we can go through all the reasons and talk about what the benefits are, being able to RSPAN traffic out of ports, being able to get better diagnostics out of the network so that I can troubleshoot things remotely and that type of thing. But it was just a hard pill for them to swallow, and they really didn't have sufficient money budgeted for it. We happened to have the IT group in the room, and the IT manager stopped and said, well, wait a minute, before we just back off of this and say, okay, let's start downgrading things. He's like, I have some money budgeted set aside to do some network upgrades. Let me look at pooling and adding that to what you've got in your capital plan, and I think we've got enough money to cover this. Sure enough, that's the way things worked out. And so that gets back to that, it being a team approach and it not being the manufacturing group trying to go out and do it on their own, or even the IT group trying to go out and do it on their own, because oftentimes they're not going to take into consideration everything that needs to happen from a top-down perspective. So it's just critical that you have buy-in basically throughout all the different levels of your organization as you go through this process. So last thing, test and monitoring what you've installed. If I install the best network in the world, it's probably great the day I installed it and commissioned it, but the reality is over time people are going to install things that they shouldn't. They're going to misconfigure things, or you're going to have problems probably show up over time. And if you're not monitoring that network, you're not going to know that those things are happening. And unfortunately, they tend to be cumulative, right? So an initial misconfiguration is probably not a big deal. When I get enough of those over time, or if it's the wrong type of misconfiguration, I have a power outage or a blip or something of that nature, and all of a sudden things don't come back the way you expect them to. So it's really critical that you document the process, understand what you're doing, and then monitor what you've installed. So these are just some great tools that you can use to do these types of things. SolarWinds has the engineering tool set and network topology manager that's available that are great troubleshooting and diagnostic tools. Rockwell has the factory talk network manager tools that are out there. Early on, they weren't probably the most stable thing. They've actually gotten substantially better, and they give you the ability to manage switch configurations and things of that nature, which are definitely helpful. The Panduit interview software, if you're not familiar with that, is another great troubleshooting tool that you can use, and a great tool for monitoring what's going on. Cisco has obviously their tool. And whatever vendor you've chosen, if you look at Hirschman, if you look at any of the other manufacturing switch vendors that are out there, they've all got tools for doing these types of things. Yes, they're an additional cost, but if you build that into the budget up front, you've got the money to be able to do it, and it becomes very helpful. The other thing I'll mention is a system integrity and events monitor. So SIEM traffic is essentially, or syslog traffic is really produced by switches when something happens on the switch. And a SIEM aggregator is something that actually pulls all that syslog traffic together into one place and allows you to look at it. And it's very difficult to coordinate things that happen across multiple switches in a network. When I can see all of that syslog traffic in one place, it becomes much simpler to troubleshoot what actually happened. The other thing that's important, obviously, for that to work correctly, or maybe not so obviously, is having time be part of what you consider in your network architecture and design. So being sure that you're propagating time throughout that entire network, so when I look at the timestamps on the syslog traffic, I actually have something that I can easily collate, easily look at, and understand what has happened. So, questions, and I have a couple down here, so I'll go ahead and read these out. Can this be executed in phases to allow for continuous operation during switchover? Yes and no. So a lot of that depends on how the original network was architected and how much confidence I have in any redundant architectures that may be out there. You can definitely do it in phases, but to allow for continuous operation would definitely be a challenge unless I have that redundant architecture in place and I do feel good about it, and I can fail things over to one side, make the configuration changes on the other, and then switch things back slowly over time. If I'm readdressing, obviously that becomes even more difficult. So now I've got to actually figure out how I'm going to re-IP address that endpoint, and obviously I can't do that and have a socket connection that doesn't get dropped. So that's definitely a challenge. It's definitely something you need to think through, but there are ways to approach those problems. Again, looking at migration in phases, taking advantage of the downtime windows that you may have. If you've got an operation that runs, 365 days a year, but you got either an annual turnaround where you're down for 24 hours, or every 3 years you're down for 24 hours. That's the opportunities where you can get in and do things like this. If you're fortunate in something like a paper mill where I've got a machine outage every 30 days essentially to change felts or things of that nature, then I've got a lot more opportunities to be able to make architecture changes to the network and migrate things over time. And that's where it's critical to have thought through what things are talking to each other on the network. Wireshark's a great tool for being able to put together information like that. As long as I know what's actually out there, then I can architect a solution to migrate things over time. So next question is, all of this is premised around perimeter protection. Once you get through that perimeter, it could be a problem. How do you address that? That's where hardening is critical, right? If all I'm doing is putting in perimeter defense, you're absolutely right. I've got this nice hard outside and a soft chewy center, and once I get in, I own you. Anything that I can do to harden that network becomes a plus. And so as vendors start to release encrypted protocols, as vendors start to release mechanisms to do authentication at the manufacturing network layer, we've got to start implementing those things. From a server perspective, there's a lot of good information out there through CIS, or if you have access to it, the SCAP and STIG tools from Department of Homeland Security, things of that nature that you can look at from a best practice perspective to say, okay, have I turned off every service on a server that I don't need? Am I patching that server appropriately? And I guess one thing I'll mention in patch management is we can't just go out and deploy every Microsoft patch that comes out. That would just be an incredible disaster. We've got to have a patch management process that considers, is that patch approved by the OEM? And then can I test that patch in some kind of either small system that I don't care as much about, or actually have a test environment available to test that patch in before I try to deploy it in production? And again, having a plan and having thought through that in advance saves you from a lot of heartache later. Another thing you can leverage there, which kind of gets back to the hardening side of things, is using virtualization technology, right? It's a lot easier to back up a virtualized server than a server that's running physically on the hardware. So my ability in the event of I install a patch that breaks something to go back to a snapshot that I took of that virtual server beforehand allows me to immediately get back up and running. So those things are definitely critical. The other thing that I'll mention, I guess, would be software-defined networking and doing things of that nature. That's an evolving technology. Cisco and others have mechanisms for being able to support that. The problem becomes the endpoints that we're dealing with don't know how to authenticate with those servers. And so we still have to whitelist the endpoint, but at least we can prescribe what we expect that endpoint to be doing. And as a result of that, it becomes more challenging for somebody that gets in my network to be able to take advantage of it. What about end-to-end protection like tempered networks? So I'm assuming tempered networks, which I'm not necessarily familiar with, is more along the lines of Cisco's, I'll think of the name in a second, but essentially which requires authentication. The issue becomes, does the endpoint have the ability to participate in that authentication process? If we're talking about the switch itself, opening a port up, that's one thing. Ideally, we'd love for that endpoint, i.e. the IO module, to come up and say, this is who I am, and actually authenticate, pass a certificate, something to the switch to say, I am authorized to be here. Unfortunately, again, our endpoints in the manufacturing space don't support those types of things. Where we can do it, it's great, right? You can definitely do it on a server. You can definitely do it on maybe a Linux appliance or things of that nature. But when you get down to the actual IO endpoints and things of that nature, they don't have that ability. What about the HIP protocol? So I am not familiar with the HIP protocol, so unfortunately I cannot answer that question. Any other questions out there that anybody might have?
All right, we could wait a minute for questions if that's all right.
Good presentation. Thank you. You're very welcome. Hopefully this was helpful. I guess while y'all are thinking about any other questions, just a couple of closing comments. This is definitely a process. This is not something that you just jump into and do overnight. For those of you that are system integrators, I'll go ahead and mention that one of the things that we found early on, you go back 4 or 5 years ago, or actually 5, 6 years ago now, I guess, before any of us really were carrying any Cisco certifications, a lot of times we'd find ourselves in a CIO's office or an IT manager's office, and some of their first questions were, what Cisco certs do you have? And when you said, hey, I don't have any, but I understand the technology, they usually kind of closed their ears at that point and didn't want to continue the discussion. So I know it takes some time and takes some effort to go through the process. To be honest, in some instances, probably didn't learn near as much as I could have, only because I was already familiar with the technology and familiar with what we were doing from a routing and switching perspective or an industrial network design perspective. But being able to walk in and say, I'm a CCNAI certified individual, I have a GICSP, I have a CISSP, I have those types of things carry a lot of weight with CIOs and CISOs, and when you have that, it just adds a lot of credibility and it makes that conversation go a whole lot easier. One other thing I'll kind of mention, and I've alluded to this earlier, I was actually sitting on a panel with some security guys from a large OEM, and they asked, somebody in the audience asked the question, what's been your most interesting role that you've been in the last year? I thought about it for a minute, and I said referee, and they all kind of laughed. And I said, you laugh, but the reality is you find yourself in this room with 5 or 6 IT guys and 5 or 6 manufacturing network or OT guys, and they're all using the same English words, but they're not communicating. And being able to provide that translation and kind of be a referee between the two to say, okay, your combination of translator and referee here, here's what he says, this is what he really means. When he says this is what he really means. Well, yeah, that's what I said. Well, that's not what he heard, right? And so it's just important to kind of keep don't let emotions get in the way. Don't let yourself get worked up. Really try to understand what the end goal is. And a lot of times what maybe an IT person wants to do, the OT person is not necessarily against. They just don't necessarily understand what he means by that, or that there are ways to get there that are helpful and that are not as destructive to being able to get in and support the infrastructure as they need. I mean, most of us, we're really worried about is keeping things available, right? We don't want that 2 a.m. phone call. We want to make it something that somebody, maintenance person in the middle of the night, can easily take care of, troubleshoot, diagnose. Goes back to that monitoring and having the right tools in their hands to be able to troubleshoot the network and understand what's going on. Without that, it definitely becomes a challenge. And so, a lot of times we're worried about, IT guy works 9 to 5 Monday through Friday. Well, and then he wants to do push patches in the middle of the night on Sunday because he thinks everything's down. Well, guess what? That doesn't work so well in our world. And so taking an IT person by the hand and walking them through a manufacturing site can just be huge, right? Their eyes start to open when they realize that switch cabinet that they think they can patch in the middle of the night is actually still in use at 2 a.m., things of that nature. So it's just important to develop that dialogue, develop a rapport, and continue to work with people. So with that said, I haven't seen any other questions come in. We'll turn it back over to you, Colin, and let you wrap things up.
All right. Thanks, Larry. So on behalf of CSIA, I would like to thank Larry for this informative discussion. I'd also like to thank all those attending. We hope you found the webinar informational. When you close out of this webinar, a link is going to pop up to a brief evaluation. We would appreciate if you could take a moment to share your feedback with us. And we'd also like to remind you that a recording of this webinar will be available for viewing within 30 days of this event. Please visit the CSIA website to view this recording or a past webinar that you may have missed. And this concludes our program for today. Once again, thanks for joining us, and have a good afternoon. And thanks, Larry.